To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter, we discussed about the landslides. So like in the previous natural disasters, my dear children, we discussed the reasons for landslides, how to mitigate the bad defects of landslides. Then especially we discussed what are the pre-signs of a landslide, right? So these are the main things that we discussed under the landslides. And finally we discussed that when you are doing a special kind of a construction, right, when a certain person is going to build up a certain house or else a construction in a hill country area, we discussed that we need to follow several rules and regulations. Especially we need to meet up with the special authorities and we need to get the permission of those authorities in order to make or in order to build up those constructions, right? So those are the things that we discussed under the previous chapter. Now within this chapter, my dear children, we'll be discussing the final, right, the last and the final natural disaster that is being discussed within this lesson part. And the final natural disaster is, my dear children, it's reflecting about the lightning and thundering. So it is given the topic lightning and thundering. So first of all, my dear children, we'll be investigating what is the reason for the occurrence of thundering and lightning. What is the main reason for the occurrence of thundering and lightning? That's the main thing or the main topic that we are going to discuss within this lesson part first and foremost. Okay, so it is given here as a topic. There are tiny water droplets and ice crystals in cumulonimbus clouds. Because of air currents, those water droplets and ice crystals are rubbed each other. Thus, they become charged. You know that we discussed these things in the previous grade also. When we are discussing about the static electricity, my dear children, I think you can remember upon rubbing, right, when you rub certain surfaces each other, you know that static electrical charges are getting generated. Okay, so these static electrical charges are generated within the material, okay, can travel from one place to another if the amount of static electrical charges which is getting generated is greater. I mean, if large amount of static electrical charges are going to generate within a certain material, then these charges can travel from one place to another. But however, my dear children, in order to travel, there should be high potential. There should be a very high potential and there should be a very low potential, right? You know what do you mean by the potential, right? It's the difference between the charges. So at a certain place there should be large number of charges and at another place there should be less number of charges. In that kind of situation, charges from the higher position can travel to the charges with lower position, right? So however, in order to occur this kind of phenomena, there should be a difference. There should be a very large difference between the two potentials. So if you take clouds are made up with ice crystals and water droplets. As you can see, there are tiny water droplets and ice crystals in cumulonimbus clouds. So you know that cumulonimbus clouds, those are the ones which are recent. Those are the ones, those clouds are the main reason in creating thunderstorms. Okay, nimbus clouds. So when you take a nimbus cloud, my dear children, right? These nimbus clouds are made up with water droplets and ice crystals. Then what will happen if two nimbus clouds come in contact with each other? Then, because of air currents, those water droplets and ice crystals are rubbed each other. Now what will happen when these two, right, when there's no need to be, I mean, like when you take two clouds, if one cloud come in contact with the another, then we can observe a good phenomena of thunder. It's because thunder and lightning also. It's because now these two clouds are getting rubbed each other, right, upon having air currents. But if you take just a one nimbus cloud, that is also enough, because upon having high amount of air currents, the ice particles and the water droplets contained within the nimbus cloud will get rubbed each other. Now upon this rubbing process, you know that particles are getting charged. Here the particles which are getting charged are ice crystals and water droplets. So here it is given, because of air currents, those water droplets and ice crystals are rubbed each other, thus they become charged, right? So when two nimbus clouds come close to each other, we can observe this phenomena very well. However, one is also enough. No problem. Okay. Then here what will happen mainly is, upon having air currents, the air particles and the water droplets and also ice crystals contained within the nimbus clouds are getting rubbed each other. Upon this rubbing process, my dear children, these particles are getting charged, right? They are getting charged electrically. So that's why these things are referred as static electrical charges. Then positive charges collect in the top layers of the cloud and negative charges collect in the bottom layer of the cloud. Positive charges are generated on the earth right below the cloud. Now here it is given that positive charges collect in the top layers of the cloud and negative charges collect in the bottom layer of the cloud. Then positive charges are generated on the earth right below the cloud. So this is how the charges are going to appear if you take these particles. If you take a certain cloud, my dear children, positive charges collect in the top layers of the cloud. On the topmost layer, we can observe the positive charges. Upon rubbing process, charges are going to appear. Now these positive charges can be observed within the top layer of the cloud. Okay. Then negative charges collect in the bottom layer of the cloud. Negative charges can be observed within the bottom layer of the cloud. Positive charges are generated on the earth right below the cloud. And also positive charges are generated on the earth right below the cloud. So this is how the arrangement of charges can be observed within a nimbus cloud. Then what will happen? When the amount of charges reach a certain level, an electrical discharge occurs. It is known as lightning and thundering. Now at a certain level, my dear children, you know that after the generation of charges, you know that the potential difference is going to increase from time to time because of the generation of charges. So in that case, at a one instance, what will happen? There will be an enough potential to move charges from one particular region to another particular region because of the difference or the potential difference between the positions in two charging at the two chargers. Okay, so upon having this potential, right, upon having this potential difference, charges will travel from one particular place to another. So this traveling of charges, static electrical charges from one place to another between clouds or between earth and a cloud is referred as lightning, right? This is the one which is referred as lightning. So when lightning occurs, my dear children, a heavy electrical discharge occurs. Heavy electrical discharge. This is electricity. In lightning, we can observe electricity, right? So these strokes are electrical strokes which are running from high potential to lower potential. So here it is given, when the amount of charges reach a certain level, an electrical discharge occurs. It is known as lightning. And you know, thundering is the sound which is given out after the discharge of electrical charges. A terrible sound is given out, so that sound is the one which is referred as thundering. So lightning is the effect which is given in these figures. As you can see within these figures, you can clearly observe. So this is the nimbus cloud. From the nimbus cloud, my dear children, an electrical discharge is given out. See, an electrical discharge is given out. So this electrical discharge is the one which is referred as lightning. Now here you can observe it very clearly, right? So this electrical discharge which is coming from the sky, from the cloud towards the ground, is referred as the lightning. Mainly, the main reason for the occurrence of lightning then is the electrical discharge. How does the electrical discharges are going to occur? It's because of the rubbing process, right? It's because of the rubbing process. Due to upon rubbing or because of rubbing process, static electrical charges are getting generated within the cloud. So these static electrical charges are going to travel from a cloud to a different place. So this electrical discharge is the one which is referred as lightning. Okay, lightning. So after the electrical discharge, my dear children, we can hear a certain sound. So that sound is called the thundering. So thundering and lightning. Okay. So the main reason for the occurrence of lightning is static electrical charges generated within the clouds, cumulonimbus clouds. Okay, right then. So according to the way of electrical discharge, there are three types of lightning. Now, my dear children, according to the electrical discharge method, according to the way of electrical discharge or according to the method of electrical discharge, you know that a certain type of charges or certain type of electrical charges are going to discharge, right, from one place to another. Actually here, from a cloud to a different place, you know that electrical charges are going to discharge. So according to this discharging method or according to the discharging position, there can be three types of, right? There can be three types of what? There can be three types of lightning. So within this figure, you can observe those three lightning processes. Number one, my dear children, a lightning can occur from cloud to another cloud like this. Between two clouds, an electrical discharge may occur. From one cloud to another cloud, electrical discharge may occur. So it is called as cloud lightning. Okay, in simple, it is referred as cloud lightning. So in cloud lightning, my dear children, what will happen? An electrical discharge or static electrical charges generated within the nimbus cloud will travel to another different cloud because of having two different potential differences. Okay, because of having two potentials. right? Because of having two potentials, from one cloud to another cloud, an electrical discharge will occur. So this is the first one, cloud lightning. Then here you can observe another one. Here there is a cloud, right? There is a cloud, and from this cloud to air particles or for the atmosphere, a lightning stroke is coming. This is called as air lightning, my dear children. Why it is called as air lightning? Very simple. From the cloud to the atmosphere or to the air particles, an electrical discharge is going to occur. Right? To the atmosphere or to the air, this electrical discharge is going to occur. So therefore, it's very simple. This is referred as the air lightning. Unlike the cloud lightning, it's not going to occur to a cloud, but to empty space, to our atmosphere. That is why it is referred as the air lightning. So the second process is air lightning. In air lightning, what will happen? Here the lightning is going to travel from a cloud, from a nimbus cloud to atmosphere or to air. Okay. So this is the second one, second lightning process. Then the third one, number 3. So when I'm going to speak about, or when I'm speaking about these cloud lightning process and as well as air lightning process, these two lightning processes are not that much harmful for human beings, because you know that normally we are living on the ground now. We are not living on the space. So air lightning is not going to harm, right? Air lightning is not going to harm for the people, because we are living in the land or we are living in the ground. Cloud lightning is also the same. It's not going to harm the people, because we are not going to live on the clouds now. We are living on the land. So these two lightnings are not that much harmful for the human beings. Okay. Actually, the harmful one is the third and the final type of lightning discharge. This is called as earth lightning. This is called as earth lightning. Here, my dear children, what will happen? Electrical discharge is going to come from a higher potential to a lower potential. Here the lower potential is the earth. So an electrical discharge is coming towards the earth, my dear children, right? Electrical discharge is coming towards the earth from a certain cloud. This is the one, this is the third and the final and the most dangerous one of all, the earth lightning. Okay, because as you know that people are living on the earth. So if a certain person is on here, then he will be electrocuted because of having lightning. Okay. So the third and the final one is the most dangerous one. So let's see. Number 1, earth lightning. So this is the number 1, earth lightning. So in earth lightning, what will happen? Earth lightning is an electrical discharge that transfer from a cloud to the earth. As you can see here within the figure, from a certain cloud to the earth, electrical discharge is going to occur. So this electrical discharge which is going to occur from a certain cloud to the ground or to the earth is referred as earth lightning. It is referred as earth lightning. Then the second one, cloud lightning. So this is cloud lightning, number 2. Cloud lightning is an electrical discharge that transfer through the cloud or between two clouds. So, like I said in the earlier case, my dear children, when the electrical discharges are going to happen between two clouds or within the interior part of the cloud, from certain cloud to another or within the cloud itself, then this is called as a cloud discharge or cloud lightning. Okay, a cloud lightning. Here the lightning stroke or the electrical charges is going to travel from one particular place to another particular place, but however between two different clouds or in the same cloud. This is cloud lightning. So cloud lightning is not that much harmful for us. As we are not living in the clouds, it's not harmful for us. Then the third, number 3, right? This is called as the air lightning. Okay, so air lightning is an electrical discharge that transfer from a cloud into the air. Now, from a certain cloud, electrical discharges which going to happen to our atmosphere or to air is referred as the air lightning. Here the electrostatic charges or static electrical charges generated are going to discharge to our outer environment, in simple, for the air particles around us. This is referred as the air lightning. Air lightning. So, like I said, my dear children, air lightning is also not that much harmful for human beings, right? The only hazardous one among these three for the people or for the human beings is the earth lightning. Right? Earth lightning is the hazardous incident out of these three lightning situations. Right? So there can be 3 types of lightning. What is that? One is cloud lightning. Here electrical discharge is going to occur from one cloud to another or within the cloud itself. Then the second one, earth lightning. Here the electrical discharge is going to occur from cloud to the earth, earth lightning. Then number 3, air lightning. Okay. Here from a cloud, electrical discharge is going to occur to our atmosphere or to air, the air lightning. So these are the 3 main types of lightning that we can observe. Okay, 3 main types of lightning. Okay then, now studying about the discharging of electrical charges. Now like I said, my dear children, I told you that this discharging of electrical charges is the main reason for the occurrence of, right? That's the main reason for the occurrence of lightning. I told you that static electrical charges are getting generated. Static electrical charges are getting generated within materials when they get rubbed each other. When materials are get rubbed each other, static electrical charges are getting generated. Okay, static electrical charges are getting generated. Now, by doing an activity, we are going to show that static electrical charges are going to generate in a material, right, upon rubbing. By doing an activity, we are going to show that. Now, this is that activity. So, this activity is very simple. You will be needing 2 polythene stripes. Okay, you will be needing 2 polythene stripes, or else you can use a same polythene stripe, a longer, lengthier one, and you can fold it to 2 equal portions. Okay, so I'll write So you'll be needing 2 polythene stripes, or else you can use 2 plastic stripes as well. 2 plastic stripes or 2 polythene stripes, right? So instead of 2 polythene stripes, you can use just 1, because you can fold this thing one on another in order to rub, right? When you are doing this activity, you can use a somewhat lengthier polythene stripe, and you can fold one on another. Okay. So however, you'll be needing 2 stripes or one lengthier one if it is a polythene, right? So what you have to do in this activity is, you need to take these 2 polythene stripes and you have to keep the finger in middle, and you have to drag along, right? Drag along. Upon dragging, you know that our fingers and the polythene stripe are getting rubbed each other. So upon this rubbing process, my dear children, now when you are doing it from time to time, right, the rubbing process is also going to happen from one time interval to another time interval. In that case, what will happen? Upon the rubbing process, definitely static electrical charges are going to generate. Now the specialty here is that as we are rubbing the same 2 material, our finger and the polythene, the charges which are getting generated on the polythene is going to be same, right? These charges which are getting generated within the polythene stripe are going to be same, because the same material is getting rubbed each other. So after rubbing and releasing our finger, we can observe that the 2 stripes are getting repelled away from each other. It's because of the static electrical charges which are getting generated upon rubbing, right? So I'm going to show you by doing this experiment at our laboratory. Okay, so you also try to do this thing at your home. It's very simple activity to investigate about the electrical charges, right? So this is how to conduct our activity then. So let's go and see the method, my dear children. So you'll be needing 2 polythene stripes. Those are the materials you need. Okay, right? Then we'll go for the method. See, the method is very simple. Keep 2 plastic stripes. Plastic means here we are using polythene stripes. Okay, so to keep 2 plastic or polythene stripes, one over the other, hold them from one end to hang down. As you can see within the figure, you have to hold it from one end. Rub the 2 stripes down firmly using your thumb and another finger. Now you can place the thumb like this and you can rub it like this. Okay, you can rub your finger by inserting your middle finger into the, between the 2 stripes. You can rub it along by using your thumb. Okay, then rub the 2 stripes down firmly using your thumb and another finger. Observe what happens. Then what you have to do, then you have to observe what is going to happen. Then try this activity using stripes of transparent sheets. As you can see here, these are the 2, here I have used only one polythene stripe. So this is that polythene stripe. So I'm going to keep it like this. Then I'm going to insert the middle finger between the gap. Then I'm going to drag along like this. Then after some time, I'm going to observe what's going to happen. So this is that thing. Like I said, my dear children, what will happen? After some time, because of generating same type of electrical charges, definitely these 2 stripes should move away from each other. I mean, they should repel each other. So this would be our observation. Definitely, for sure, this would be our observation. But however, we need to carry out this activity in order to see whether this thing is going to occur or not. Science is that thing, no. Science means, my dear children, we are going to conduct a certain experiment by doing a certain hypothesis. Hypothesis means we are going to imagine now this kind of an incident is going to occur because of this kind of a reason. So according to that reason, we are generating or we are experimenting the hypothesis. Okay. So according to that experiment, we are going to take several observations. So if the observations are same as our hypothesis, then my dear children, our hypothesis is correct. If the observations are somewhat different, then our hypothesis is wrong. So from that, we can come into a conclusion. This is what is science. In science, basically what we are going to do is we are developing several experiments and we are taking several observations to come into conclusions. That is how the science is going to work. Each and every scientific principle in our world was found by following that scientific method. Experiments, first of all hypothesis, then experiment, observations, finally the conclusions. So here also we are going to investigate how the lightning is going to occur. Lightning is going to occur mainly because of the electrical charges. So by doing this activity, we can prove that lightning is a type of electrical discharge, my dear children. So let's head on to the lab. We'll see whether this thing is going to occur or not. Right? So I'm going to conduct the same experiment in the laboratory. Then we'll observe whether this thing is going to happen or not within the polythene stripe. So let's head on to the lab, my dear children, and we'll conduct the activity. Then we'll once again come back to the classroom to write down our observations and our conclusions. So my dear children, to study the effect of static electrical charges, now I have with me a piece of polythene paper, right? As you can see here, now this is the polythene paper, right? So when I'm going to release that end, actually it's going to hit on the other half of the polythene paper, and you can see here that we can clearly observe the two ends. See? Now what I'm going to do is I'm going to rub it against a material. You can rub it against, like this. But however, to get more convenient observations, what I'm going to do here is I'm going to use this plastic pen and I'm going to rub it against the surfaces of the polythene paper. And after that, we'll observe whether these things are remain in the same position or getting attracted or getting repelled each other. Okay? Right now, I'm going to keep it like this. And now, let's rub it by using the plastic pen. And the other side also. Now, let's see what's going to happen. So now, as you can see clearly, unlike in the previous case, these things are not getting attracted each other. Always one another is going to face the other side. See, these two surfaces are not facing each other. They are not attracting like the previous case. So when I'm going to keep this pen near, right, like this, so we'll recharge it once again. See, there is a clear gap between the two stripes. You can see that there is a clear gap between the two stripes. Like in the previous case, the two stripes are not getting like closer to each other. They are getting repelled each other. Because same types of static electrical charges are created between these two right now. as I have rubbed the same material with the plastic pen with me. So my dear children, it's clear to us that upon rubbing materials together, right? Upon rubbing materials together, we can generate static electrical charges. So these static electrical charges are the ones which are responsible in creation of lightning. So let's head on to the classroom once again and we'll study what are the other things contained within our lesson. Right. So as you observed, my dear children, we conducted the activity and you could observe that from the lower end, the two plastic or the two polythene stripes are going to repel each other. Now, the reason for this repel, right, reason for this repelling is that static electrical charges are getting generated. Especially, my dear children, same type of static electrical charges are getting generated within these two polythene stripes. As I'm going to rub it along the, right, you could see that as I'm going to rub it along the polythene stripes, I'm going to rub my finger against the polythene stripe. So same material is going to rub each other. So from grade 7, we have studied that if same materials are going to rub each other, then same types of charges are the ones which are getting generated. So if same charges are getting generated, always we can observe a repulsion, right? Always we can observe a repulsion. So we'll write down our observation, my dear children. Our observation was quite simple. What has happened over there? If this is the polythene stripe, it went like this, right? It went like this from the bottom. Okay. So we can write our observation. Two ends of the polythene stripes repelled each other according to the figure. Right, according to the figure, the two ends of the polythene stripes repelled each other. So two ends of the polythene stripes repelled each other according to the figure. So what is the conclusion then? Why the two ends are going to repel like this? It's because the polythene stripe now charged with a same type of static electrical charges. So in simple, we can say that polythene stripes are charged with static electrical charges. So we can write the conclusion. Static electrical charges are generated on materials when rubbing. So our final conclusion is that, my dear children, static electrical charges are generated on materials when rubbing. So when rubbing, my dear children, you know that static electrical charges are going to generate. So this is how static electrical charges are getting generated within the clouds. So when those clouds are getting rubbed each other, right, when those two clouds, or when a same cloud, when you take a same cloud, when ice particles or ice crystals and when water particles, when they are getting rubbed each other due to air currents, an electrical charges, type of an electrical charge is going to occur within the clouds. So at a certain moment, these electrical charges will come down. This is the one which is referred as the lightning then. Okay. So finally we can come into a conclusion that charges are going to occur. Electrical charges are going to occur. Static electrical charges are going to occur when materials are get rubbed. Okay. So this is our activity. This is our conclusion and our observation, my dear children. Okay. Right then. So we'll head on to observe what are the other contents. So a column given under the extra knowledge. Voltage of a lightning stroke is about 100 million volts. Electrical energy generated in lightning is very high. Electrical current of a lightning is about 25,000 amperes. Current flowing through a bulb of 25 watt. Let's forget about that thing. First of all, we'll discuss about this first main point which is given here. Voltage of a lightning stroke is about 100 million in volts. Now, usually, my dear children, when you take the voltage of a certain type of a electric discharge, especially when you take a lightning, in a lightning stroke, the voltage is around 100 million. 100 million volts. If you take a dry cell, a simple dry cell is containing only 1.5 volts. The household electricity in our normal plug sockets, there is a voltage of 230 volts. So that 230 volt is also lethal for us. Okay. So imagine how much lethal is going to be a lightning stroke. It carries 100 millions of volts. Very high potential difference. That's why even it is coming towards the ground without any conductors, my dear children. You know that in order to transfer electrical energy from one particular place to another particular place, we have to provide a certain type of a conductor. Conductor means a material that can conduct electricity. Without a conductor, electricity will not travel. But however, my dear children, if you take a lightning stroke, now lightning stroke is also a type of electrical discharge. No, in simple, we can say that it is electricity. I told you earlier that in order to pass electricity from one place to another, there should be an electrical conductor. But my dear children, the amazing thing in here is that if you take a lightning strike or lightning stroke doesn't need any electrical conductor when passing those electrical charges from outer sky or from cloud to our ground. There's no certain type of a conductor to travel, no. That light energy or that electrical energy is coming towards the ground without a conductor. It's because of the amazing, or the extreme amount of potential difference which is getting created here. The cloud is having 100 millions of volts. However, the ground is only having 0 of volts. We imagine that our ground is neutral. There is no certain voltage in ground. We assume that the voltage in ground is equal to 0. Actually, it is true. If the ground is having certain amount of electricity, then we will be get electrocuted now when we are walking. But such incident is not going to occur. So that means, my dear children, our ground is neutral. The voltage in our ground is exactly zero. There's no voltage. There's no potential difference in our ground. So we assume that the ground is zero. The voltage in our ground is zero. If the voltage in our ground is zero, right? If the voltage in the cloud is about 100 million, then there is a huge difference, huge potential difference, 100 millions of potential difference between the cloud and the earth. So, my dear children, what will happen? Right? We can clearly observe an electrical discharge without any conductor. Without any conductor, we can observe an electrical discharge. So that extreme potential difference is the main reason for the occurrence of a lightning stroke. Okay. So here, the electrical energy generated in lightning is very high. Electrical current of lightning is about 25,000 amperes. Now, the second important thing is, if you measure the electric current, it's nearly about 25,000 amperes. Nearly about 25,000 amperes. Usually in our household electric circuits, in our normal plug sockets, we'll be receiving maximum up to 13 amperes. We'll be receiving up to maximum 13 amperes of current in our normal household electric circuits. 13 amperes of current. From plug socket, we will be receiving only 13 amperes of current. If you take a lightning stroke, it's like 25,000. It's a huge amount of electric current. So you can't imagine, even we can't imagine the amount of electrical charges, the amount of energy which is being stored within a lightning stroke, right? Huge amount of lightning, right? Huge amount of energy is stored within lightning. Here it is given, current flowing through a bulb of 25 watt is about 0.1 amperes and voltage of household electric supply is 230 volts, right? So to compare the electrical energy contained within the lightning stroke, you are given with this point. If you take 25 watt light bulb, from that light bulb, the current which is passing is nearly about 0.1 amperes. And the household electricity, if you take household electricity, I told you, the voltage in household electricity is about 230 volts. So imagine the difference, my dear children. So we are talking about huge amount of electricity. We are talking about huge amount of electricity in a lightning stroke. Then, lightning danger is common during intermonsoons in Sri Lanka. Now the next thing is, during the intermonsoonal rains, when there are convectional rains, my dear children, we can observe more amount of lightning. Okay, more amount of lightning can be observed during the intermonsoonal season. Maximum number of accidents due to lightning were reported during the month of April. Now this is very important. During the month of April, right, most number of lightning accidents can be observed in Sri Lanka. Most number of lightning accidents occur in Sri Lanka in the month of April. Okay. So more than 50 deaths are reported due to lightning. So when you take this month, right, during the month of April, my dear children, in each year, more than 50 deaths are being reported due to lightning, right? So most of the times these lightning accidents happen in April. But however, when you take the whole year, more than 50 deaths are going to happen because of the lightning. Most of the lightning deaths are going to occur within month April because of having intermonsoonal rains. Okay, intermonsoonal rains. Then here it is given once again, tall buildings and trees are easily subjected to the hazard of lightning. The reason for this is that tall places provide the shortest path for the discharge of lightning from the clouds. Now, the other thing is that I told you that in order to travel lightning or in order to travel electricity, my dear children, we'll have to provide a certain conductor. Right? We'll have to provide a certain conductor. Conductor means any kind of a material that can pass electricity from one place to another. Most of the times, if you take a metal is a good conductor of electricity. Then salt water, acidified water. Acidified water means like when you add a certain acid, so when you add certain drops of acid to water, right? When the pH value is somewhat near to acidic level, that means if the pH value is somewhat less than 7, then that kind of water is considered as acidified water. Acidified water is a good conductor of electricity. It can conduct electricity very well. Human body can also be taken as a conductor, because you know that our body is going to provide, our body is going to produce sweat. Sweat contains salts. So our body is also a good conductor, good electrical conductor, right? Then, if you take tall buildings, my dear children, now most of the times lightning is going to occur upon rainy days now. So taller buildings that has water can be considered as a conductor, right? During the rainy season, definitely the lightning is going to occur, right? So you won't be able to observe lightning in a warm sunny day, no. Most of the times the lightning is going to occur in a cloudy and a rainy day. So upon having rain, my dear children, the whole building is now getting covered with rainwater. So it is behaving as a conductor, because you know that rainwater is somewhat acidified. So it is behaving as a conductor. So taller buildings are much closer to clouds rather than the ground. So it is, you know that if you take lightning is an electrical discharge. So electricity would like to travel through conductors. So the tall buildings are behaving like a conductor. So my dear children, taller buildings will have a great potential or higher potential in getting electrocuted. So the tall buildings will have greater potential or greater opportunity in attracting lightning strokes, my dear children. Okay. So the so it is given that tall buildings and trees are easily subjected to the hazard of lightning. The reason for this is tall places provide the shortest distance with a good conductor, right? That's the main reason. So always remember, this lightning hazard is mainly occurring because of having that static electrical charges. Okay, static electrical charges. And the most dangerous electrical discharge for human or for the people is earth lightning. Earth lightning. So upon earth lightning, the electrical discharge is going to occur between cloud and the earth. Now within earth also, my dear children, taller buildings and taller trees, they have the highest potential those places has the highest potential in receiving a lightning stroke. Okay, because that is the shortest distance, and also during rainy season these things are behaving as good conductors because rainwater can conduct electricity. Okay, right then, so these are the key points that you need to remember, right, about the lightning. So always try to stay within the home when there is lightning. Don't go for the open places, especially don't go like now when there is raining, don't try to go under a tree. It's not suitable. As you can see, it is given here, tall trees are very hazardous. Tall trees are hazardous to lightning strokes. I mean, tall trees, they have a greater potential in attracting lightning strokes, my dear children. So if there is lightning with rain, don't go underneath a tree. Try to find out a good shelter. A house would be probable. Don't go for the open places during lightning. It's not good. Okay, because always lightning is going to find out the shortest distance to travel. Lightning is always going to find out a conductor to travel. So don't be a conductor. Always try to be an insulator. Okay, always try to be an insulator. By that way you can avoid the bad effects or the hazardous effects given out by the lightning process. Okay, right then, my dear children, so these are the basic things that you need to learn about the lightning process. Always remember, it's a type of an electrical discharge. Okay, it's a type of an electrical discharge, right? And this earth lightning is the most hazardous one for us. So don't try to be a conductor, always try to be an insulator if you need to survive from a lightning stroke. Okay, right then, so these are the basic things that we are going to learn about the lightning, my dear children. Now in the next chapter, we are going to discuss about several other things related to the lightning. Here especially we are going to discuss in our next chapter how to minimize or how to manage the lightning hazard. Okay, how to manage the lightning hazard. I mean, like in the earlier chapters, when we are discussing about the drought and the landslides, we discuss how to manage this disaster. So like that way we are discussing how to manage the disaster. But however, my dear children, we'll be discussing that thing within our next chapter. So I'll hope you to meet with our next chapter to discuss about the management of lightning disaster.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.